the first part is direct variation. And last lesson, you learn about inverse variation. So today we are going to look at combined variation. So as long as you know direct variation and inverse variation, there won't be any problem for you to solve the combined operation, combined variation. So 1.3, the last part here, combined variation. So you look at the conversation over here, they give you the learning standard. This one is in your book. Okay, the learning standard, that is to determine the relation between 3 or more variables for a combined variation. So student asks, teacher, what is the meaning of combined variation? Simple. Combined variation involves a combination of direct or joint variation and inverse variation, meaning that you are going to join y varies directly as x, y varies inversely as 1 over x, for example. Okay, so when you join two of them together, it becomes combined variation. Okay, for the mind visualization over here, I've done it. I think you don't have to go through this. It's quite time consuming. So you do that on if you really want to find out. I'll go directly to the conclusion for you. Okay, so you can get to it faster. This one. Okay, the conclusion is over here. For a combined variation, y varies x power of n and inverse z to the power of n can be written as y varies directly as m on top and inversely as z to the power of n at the bottom. Just remember, directly it will be the numerator, inversely it will be the denominator. Okay, when you change it, just need to add a k in front like this. Okay, and the same thing, value of m and n is always fixed from 1 to 3 and up to 1 over 3. N is also from 1 to 3 and up to 1 over 3. Okay, now we go to example 22 here. We can finish this very fast actually, because you already know the first two variations. So this one won't have any problem for you. It is given that y varies directly as the square of x. So y varies directly as the square of x and inversely as the square root of z. So inversely, you put it down here as the square root of z. Okay, so it is like this. If y equal to 8 when x equal to 4 and z equal to 36, express y in terms of x and z. So you're going to substitute the value of y equal to 8, x equal to 4, z equal to 36 here. Find out the value of k. So 8 times square 36 divided by 4 squared, you get 3. Hence, y equal to 3x squared over square root of z. Simple only. Okay, now we look at example 23 here. The table below shows the value of P, Q, and R. Okay, you're given P, Q, R. It is given that P varies directly as the cube of Q. So you need to show the relation first. P varies inversely as the cube of Q. Inversely means over as the cube of Q. Oh, sorry, I see the wrong thing. Directly, Q is on top. Q, Q. And inversely as R. Okay, so calculate the value of x and y, just like what you did before. So what you need to do is change it to equation P equal to K cubed 3 over R. Find out the value of K. So substitute the value of P for the first one. 4 equal to K times 2 cubed over 0.6. Find out the value of K. Okay, so I move forward now. I think you already know how to do this. So we look at the next page directly. They already show you the working easier. This one. Okay, so when you substitute the value of 4 and 0.6, you get the value of K as 3 over 10, this one. So just substitute the value of constant into the equation that you get. P equal to 3Q cubed over 10R. Okay, next, when you want to find out the value of the x and y in the table here. So you just need to substitute the value of P, 3.6, and also Q, 6. Okay, so you get a 3.6 and 6 over here. by using the algebraic formula, change everything, and you get the value of x equal to 18. Okay, same thing for the value of y. You are going to substitute the value of p. Okay, this one is p, and r is 2.7. So p is 0.081. They write here r is 2.7. Okay, therefore p is 3q cubed over 10r. You substitute the p is 0.081 and the r is 2.7. Okay, calculate it. How to calculate? You are going to move this 0.081 times 10 times 2.7. It's like this. If you understand the algebraic formula that you have learned before, 0.081 times 10 times 2.7 equal to 3y cubed. So you want to get this. Y cubed is equal to 0.081 over, times 10 times 2.7 over 3. Okay, so to cancel the cube here, you need to cube root it. Therefore, cube root it. Cancel, cancel. That's why you have this part. Okay, just press your calculator and you will get the value of y equal to 0.9. Simple only. Okay, now we move to problem solving. How to solve problem involving combined variation. So this is on page 28 in your textbook, if you have your textbook with you. Okay, here. The pressure P and m to the power of -2 on the tire of a wheelbarrow varies directly as the mass of the wheelbarrow m kg. So it will be P varies directly as m, and inversely as the surface area of the tire touching the ground, L. Okay, so you will have L like this. Then it is given that the pressure of the tire is 45,000 Newton meter to the power of -2. That is the pressure measurement. When the mass of the wheelbarrow is 90 kg and the surface area of the tire touching the ground is 0.02 meters squared. So they want you to find out the value of P when m equal to 120 and 0.5. So first thing, before you do anything, we are going to find out the constant. Okay, so change this becomes equation. It will be P equal to Km over L. Then you substitute the pressure, 45,000, okay, equal to K times M. Your M that you have just now is 90 kilogram. That is your mass. Over the L. The L that you are given is 0.02 meters squared. That's the area, 0.02. So from here, you can get the constant already. It is equal to 45,000 times 0.02 over 90. So check out 45,000 times 0.02, and then you divide by 90, you will get the value of K as 10. Okay, so when they ask you to calculate the value of P for question A here, you are going to substitute the value of K into the P here first. Okay, I write it down on the right here. P is equal to K is 10 M over L. Okay, when M is 120, so you substitute P is equal to 10 times 120 over 0.5. Okay, so last thing, you just press your calculator again. 10 times 120 is 1,200. Then you divide by 0.5. You will get the P is equal to 2,400. But the P is pressure, right? So you need to replace it with the measurement, not the unit given, which is Nm to the power of -2. Nm to the power of -2. Okay, so this is for part A. Okay, I'm going to continue with part B over here. What can be done to reduce the pressure on the tire if the mass of the wheelbarrow is fixed? So the mass is this one. If it is fixed, sorry, not this one, this is a constant. This is 10 times 120. Okay, if the mass is fixed, so you see, 10 times 120, if it is fixed on top of it, what can be done to reduce the pressure? Okay, so if this is fixed, how are you going to reduce the pressure? You can think about it. If it's fixed, are you going to increase or decrease the area, the L, the surface area?
Increase.
You got to increase it because it's the other way around. To make it decrease, you will have to increase this one so that the value of P will decrease. Okay, if the other way around and they ask you, they want to increase the pressure, then you got to decrease the value of the area. Okay, so do you have any question regarding this?
No question,
madam.
No question.
Yeah, any question? No question, huh?
No, madam.
Oh, good. So we are at the end of the lesson already for this chapter. I think this is the easiest chapter among all the Form 5 syllabus. So we go back to this, go to the conclusion directly. See whether I paste the conclusion here. Okay, the conclusion is here. Just revise back here. What did you learn in variation here? First thing, you learn the direct variation. Okay. After that, you know that the direct variation is y varies directly as n like this. There is a relation, and then you need to add the constant. Okay. And then the graph of y against x to the power of n is a straight line for a direct variation. And then it passes through the origin. Whereas for inverse variation, okay, y varies inversely as x to the power of n like this. And then the y equal to k over x to the power of n, where k is a constant. Okay, when you want to get the constant, it is y times x to the power of n like this. Okay, so the graph of y against 1 over x to the power of n is a straight line. Whereas y against x to the power of n is a hyperbola like this. Okay, that is for inverse variation. And then for joint variation you know already lah. Just add on another variable at the back. So I'm not going to talk about this. We look at combined variation that we learned just now. So it's a combination of a direct variation and an inverse variation. You just add on the constant in front of the numerator. Okay, and then it can involve a lot of variables. But then the power of all the variables, the maximum is 3 and 1 over 3 only. Okay, so that's all for this chapter. Okay, come back to your homework. So the homework that you need to do is 1.3a. You move to page 28. I want you to do, let me see, where is 1.3? Okay, this one. 1.3a, I want you to do question number 1 and also number 4. And then for 1.3b, you only have 2 exercises today. This is 1.3b. Do both question number 1 and 2. Okay? Any question, class?
No.
Right. Okay, so let me check who is not here today. There are 47 of you right now. I want to go back to this. Janwell, Jesseline. Who else is that? Amel. Amel, are you there already? Amel, I see your name, but I can't hear your voice.
Yes,
Amel,
madam.
yourself? Okay, Amel, you are there. Amel, remember to turn in your work for the previous exercise, okay?
Okay, madam.
Okay, and then for the next one, Janwell, Jesseline, not here yet. What about Gary, also not here? One more person, Sophia. Okay, Sophia, you are here already, Sophia? Yeah, Sophia, do you see your name down here for the exercise, the previous exercise 1.1c and 1.1d? You haven't turned in yet, so make sure you turn in, Sophia.
All right.
Okay, so that's all for the class today. If you have any question, you just text me through the WhatsApp, it's easier. Okay, in the following lesson, I'm going to enter into the new chapter, which is the matrices, chapter 2. Okay, class?
Okay, madam.
Yeah, you're welcome. So I'll see you on Friday. Friday is 7:10. Remember to wake up early. We will start the lesson exactly at 7:10.
All right.
Okay. Bye, everybody. Have a good day. Good day.
Have a nice day.
Thank you, madam. Thank you, madam.
Thank you, madam.
Yeah.
Bye, madam.
Thank you, madam.
Remember to
Thank you,
take your
madam.
attendance after you have done the work. Turn in your work. Welcome. Welcome, everybody.
Bye, madam.
Bye.
Yeah, welcome.